Hello students, welcome back to HP Kapadia School. Okay, myself is Kunal Pandya and this is my introduction on the screen. So as I have told you, we are going to study something about instantaneous velocity, instantaneous acceleration and all. But before going to those topics, it's very important to go through this topic, and that is the mathematics which is related to physics. Okay, see, you might have learned that some students are lagging behind in the physics, and the main reason behind that is the math part which is related with the physics. Okay, so physics is very easy if you know the mathematical concepts very well, and this mathematical concept which we are going to study today is a differentiation and integration. Okay, these are the two topics which we are going to study today. Actually, these two topics are there in the maths syllabus of 12th standard students. Okay, so it means the things which we are going to study will be studied by a mathematics student in their maths syllabus in standard 12. Okay, but we will deal with some important formulas of this differentiation and integration which is written on the screen, and this is the part of calculus which was made by Newton. Okay, so it's very important. Please concentrate in these lectures, and if you have any doubt you can ask me in the comment section. So first of all, we'll go with the differentiation. See, we are not going to derive any formulas today because actually the formulas of differentiation and integration are not actually derived by the math students in their math syllabus also. Okay, it is for the higher level mathematics. If you are doing MSc or BSc, in that you will be deriving the formulas of integration and differentiation. So over here we will accept all those formulas without any proof. Okay, so let's start with differentiation. Okay, differentiation is something which is which is related with the difference of something. Okay, like if we subtract anything, imagine the temperature of Ahmedabad today is actually 45 degrees Celsius in afternoon, and in night it becomes suppose 20 degrees Celsius. Let it be T initial, let it be T final. Then we can say decrease in temperature becomes delta T is equal to final temperature minus initial temperature. We will be getting minus 25 degrees Celsius. Okay, so this is the basic mathematical thing which you know, that whenever we are taking whenever we are subtracting or we are finding out any change, they are always doing final minus initial. But what does this delta indicate? Okay, delta is there in this equation. This delta indicates change. Okay, delta indicates change. Okay, change of what? In this case the change is that of temperature. Okay, here the temperature is changing, therefore it is written delta T. So most important thing about this small example is that you learned that delta indicates change. Okay, this delta indicates change. Okay, actually it indicates very large change also. Okay, so change, or if the change are very large, we are using delta sign. Okay, so always remember delta is the sign for change. Okay, now let us imagine another case that your weight is, suppose weight and mass are different. Let your weight is suppose 60 kg in the morning, and in the evening if it becomes 60.00000002, then we can say this is suppose initial, this is suppose final. Then your change in weight will be delta W is equal to 0.2467, we can 0.00000002 kg. Okay, actually it should be Newton. I am writing Newton. Also should be in Newton. Kg is a commercially also we can write in Newton kg also, but according to physics it will be wrong. So here the weight will be, the change in weight is 0.00007 times 0 and 2. So over here the change is there, but change is very small change. Okay, the change is very small. We are writing delta, okay, into d. Okay, we have to write d instead of delta. So formula will become like, sorry, our equation will become dw is equal to 0.7 times 0 and 2 Newton. So delta gets converted into d when the change is very small. Okay, if change is very small, the delta will get converted into d. Let's see once again. If the change is like this, if initial the time is suppose 10 seconds, and after some time, very less time, the time becomes 0.00001 second, then instead of delta we will write indicated d for this small change. Okay, so for very small change we have to write dt. Okay, now the question arises how small the change would be. Okay, so the small change will depend on the reference. Okay, which reference we are taking, that will decide what is the value of d. Okay, so let us take an example. This is an example in which is the Hulk. Hulk is moving towards a tree. Okay, there is Hulk, and this, let me write. Some people might not know who is the Hulk. Some DC people also will not know who is Hulk. Yes. So this is Hulk, and the distance between Hulk and tree exactly from the punch of Hulk. Okay, which is at this point to this point of the tree is suppose 64 meter. Okay, this is the 64-meter distance. Initially, the distance between tree and Hulk is 64 meter. If Hulk is told to cover half of the distance which is remaining in each phase, okay, in each phase he has to cover half of the distance which is remaining. Right now the distance is 64 meter. So in first phase he will cover half of the distance. So we can say he will cover 32, and the remaining distance also will be 32 meter. So this is the first phase. In another such phase, if he covers half of the distance which is remaining, we can say the distance will be 16 meter, and in such phases we can say the distance between these two will be 4 meter. So if you take a calculator and if you just divide the given values by 2, for example 64 by 2, then again by 2, again by 2, if you just go on dividing those values by 2, then you will not get the answer to be 0 exactly. Okay, yes, there are limitations of calculator. Calculator might show you the 0 answer, but you very well know that the answer will not be 0. Answer will be very near to 0, but not exactly equal to 0. So the very smallest value that you get will be a very small distance between the Hulk and tree. Okay, so after such very large phases, okay, the distance is getting divided by 2 each time. After such 10,000 or infinite phases, the distance will be like this. Okay, at last the distance between Hulk and the tree, okay, if we zoom this part, okay, we will be getting some distance. Okay, there will be some distance over here. I am just highlighting that part. Okay, so there will be distance between this line. Okay, see here, over here I am highlighting this thing. Okay, over here we will have some distance. Okay, and again if we divide this distance divided by 2, again we'll get the answer. In that case, after such very large time, we can say that the Hulk is not exactly touching the tree, but Hulk tends to tree. Okay, what is the term? Listen it carefully. After such very long phases, we can say Hulk tends to tree, but the limit is not touching the tree. So therefore we will write limit Hulk tends to tree. Okay, so the meaning of this thing which I have circled is exactly this one. Okay, this is the Hulk, this is the tree. Hulk tends to tree means Hulk is very much near to tree, but the limit is he is not touching the tree. If the values are very much near to the other value, but it is not exactly equal to that value, then we can say the value tends to that value. Let me write in detail. Imagine, in this case, we can write limit Hulk tends to tree. Okay, the symbol is for tends, T-E-N-D-S. Okay, so this is how we can write in mathematics. In physics also we'll follow this thing. Now let's see another example. Imagine a person A is scoring 34 marks in physics. Okay, physics is getting 34 marks out of 100, and imagine 35 is the passing mark. Okay, passing mark is 35. He is scoring just 34 marks, and person B having the worst result, he is getting suppose 4 marks in physics. So practically you can say both of them are failed. Okay, A is also failed by 1 mark, B failed by 31 marks. So both of these students are failed. But in order to maintain his dignity, that this student A can say that I tend to pass, or we can say student A tend to pass. Okay, and you have to write limit. This thing will mean that this student A is very much nearer to pass, but the limit is he is not getting passed. Okay, so this is exactly what the symbol says. Okay, we cannot say that B tend to pass. Okay, or we can say B tend to, yes, B is getting 4 marks, but we cannot write in this case like this limit B tend to pass. Okay, we cannot write this thing because he is nowhere nearer to the passing marks. Okay, A is near to the passing marks, therefore we can write, but in case of B, will not be able to write that way. Okay, so this is exactly the meaning of limit and tends to. Okay, now without wasting time, let's see the important formulas of differentiation. The formula number 1 is d by dx. Now let me tell you what is d by dx. Is actually an operator, or it is the function. Now what is the function? Let us take an example. Sin theta by cos theta is equal to, you know, it's tan theta. Yes, it's very easy. Sin theta by cos theta is equal to tan theta. But so if you are getting this answer in your mind, that sin theta by cos theta is equal to tan theta, then you are on the correct path. But if you feel that it is in by co, okay, what is in by co? Let me tell you. In by co was a great discovery by some of the great students. I will not tell you the name. In by co comes from this thing. See, this is S, and S will get cut out. Theta also gets cut out. So we'll get in by co. Yes, we'll get in by co. Do you think this is possible? No. It's not like this. We cannot cut S and theta over here. Okay? It's not possible. So similarly over here, d by dx as a whole is a function. Never try to cut. Okay, again listen it carefully. Never try to cut this d and d. Okay, it's as funny as cutting this s and s, theta and getting the answer in by co. It is in similar way we cannot cut d and d over here. Okay, so d by dx as a whole is a function. Okay, it is a formula of something. I will tell you that what is the formula related with that thing. Is formula number 1 of differentiation. D by dx of x raised to n. Please don't get shocked. Okay, it's very easy. I will teach you. By the end of this lecture, you will have some confidence about differentiation. It can also be written as dx n by dx. Okay, don't worry. In some part of the textbook, you can also have written like this. Okay, so don't worry for that thing. It's d by dx of x raised to n. If differentiation, this whole thing is called differentiation. Okay, differentiation of x raised to n is equal to, the answer of this thing is nxn minus 1. As I told you before, we are not going to derive this formula. We have to accept this as it is, and with the help of this formula we have lots of applications. So we'll deal with the application part of this thing. So d by dx of x raised to n is equal to nxn minus 1. Similarly, d by dy of y raised to 8 will give. So let's see. Yes, some students got the answer, got the idea, but all the students may not be the same. For me, all the students are equal. Yes, so this is n. I have written n over here. Similarly, if this is 8, then what we will write over here? Yes, some student just understood this thing. We will write 8 over here. Okay, this is x. I will again write x on the exponent of x on the right hand side. I have written n minus 1. See, this is n minus 1. So over here what we will write? So we will have to write, instead of n we have 8, so therefore we'll write 8 minus 1. So I will be writing 8 minus 1. Understood? So it is very easy. Follow the blue shades and yellow shades given over here, and you will understand the formula. So finally the answer will be 8x raised to 7. Okay, this was one of the examples. Let us have some other examples also. D by dt of t raised to 8, or we can say t raised to, let us take 2020. Year 2020, it's very long, I feel, for some students. Yes, so 2020 t raised to 2019 will be the answer. It's very easy. Okay, again let's take another example. D by dp of p raised to, let us say 50, then we can have answer to be 50. First of all, write this exponent here, deduct 1 from 50, we will get 49. So our answer will be p raised to 49. Okay, so that will be our answer. So if you are having any difficulty, I will suggest you rewind this video, see it in some lesser speed, and you will be able to understand it better. Okay, so this was the formula number 1. I will suggest you should write this thing in your notebook so that you can understand it better. Okay, and in the future, I mean in upcoming slides, I will be asking you this again and again. Let's see the formula number 2. Okay, let's have one question for you people. Please tell me the answer of this thing. D by dx of, sorry, d dy dx of just x is given. What will be your answer? D by dx of x, what is the answer? Tell me in comment section. Okay, you have to write it in comment section. What will be the answer of d by dx of just x? Okay, so I will be waiting for your comments. This was the formula number 1. Let's say formula number 2. Formula number 2 says that differentiation of constant is always 0. Okay, constant is something which will not change. And what does small d indicate? Over here small d indicates a very small change. Okay, so change in constant. Okay, the statement itself seems to be contradictory. There is never a change in any constant, so therefore the change in constant is always 0. So if there is a constant, then the differentiation of constant is always 0. Okay, similarly if we have d by dx of 5 is a number cannot change by any means, we'll have answer to be 0. Again, d by dy of 8 or whatever number you like, d by dt of pi is also a number, answer will be 0. So for constant, always the answer will be 0. Okay, so this was the second formula. Now let's proceed to the third formula. Formula number 3, d by dx of kx raised to n. Now we have also a constant, also we have a variable. In that case, what we have to do, we have to take out the constant part. Okay, first of all, take out the constant part. This is the constant. Take out the constant from differentiation. So we'll get d by dx of x raised to n. Okay, now the answer of d by dx of x raised to n, if you have written, as I have told you before, the formula number 1. Okay, the formula number 1 suggests this thing. We'll get k n x n minus 1. Okay, that will be our final answer. Let's have an example. If we have d by dt of 10t raised to 30. So in that case, what we have to do, first of all, take out 10 outside the differentiation. 10 d by dt of t raised to 30. That will give 10 into the answer of d by dt of t raised to 30 will give 30 t raised to 29. So finally our answer will be 300 t raised to 29. Okay, so that is our answer. So I will suggest you should write this thing right now by pausing this video. So let's proceed further. Again, let's solve some numericals like this also. Let us have d by dt of 20 t raised to 5. So in that case, the shortcut is you have to just multiply these two. Multiply 5 and 20, you will get 100, and deduct the power by 1, you will get t raised to 4. So 100 t raised to 4 will be your answer for this case. Similarly, if we have d by dy of 50 y raised to 11, in that case you will get 550 y raised to 10. Okay, we have to multiply 50 and 11, that will give 550, and if we deduct power by 1, we'll get 10. Okay, so this is how we can do the numericals related with third formula. Now the formula number 4 is also very easy. The formula number 4 says that if we have d by dx of f and g, where f and g are some variables and not constants. Okay, if they are constant, then answer will be 0, but if they are not constant, we will do like this. Just open the bracket, which the way which you were doing in 10th standard, d by dx of f plus d by dx of g. Okay, that will be our answer. For example, if you have d by dx of x square plus 2x raised to 4. Okay, so in that case, just we have to open the bracket, d by dx of x square plus d by dx of 2x raised to 4. That will give 2x. The differentiation of x square will give 2x. If you are not able to understand, again I will suggest go to the formula number 1 and try it again. Okay, and d by dx of 2x raised to 4, that is the third formula, we get 8x raised to 3. Okay, so this will be our answer. So this is enough for differentiation part of third chapter. Now we'll proceed for the integration. Okay, so if you are able to understand this much things in differentiation, then it's enough. Okay, but don't forget, I will be giving you the worksheet to solve, with the help of which it will boost up the concepts of differentiation. Okay, so let's see the another part of mathematical concepts, that is integration. Okay, see, just always remember what is differentiation. Differentiation means dividing something, okay, or we can say subtracting something. So just remember, this is called differentiation, that is we are dividing something, and if we gather something, then it is called integration. So this is called integration. Okay, by adding means integration, differentiating, or we can say taking the subtraction sign gives the differentiation. Okay, no doubt the formulas of division, subtraction will not match with the formulas of differentiation. Similarly, the formula of addition and multiplication will not lead to the formula of integration. Both differentiation and integration have different formulas. Okay, so let's see what is integration. First of all, in statistics chapter of 9th or 10th, I don't know, we have studied this thing, x1 plus x2 plus x3 plus x4. If we have some numbers like this, then we can add these as sigma. Okay, sigma stands for the summation. summation from 1 to 4, I can write it is I is equal to 1 to 4, and just we have to write xi. Okay, this is the way in which you were writing in your 10th standard, okay, or 9th standard. Similarly, if you have a value like this, delta y1 plus delta y2 plus delta y3 up to delta yn, then you can write it as sigma I is equal to 1 to n delta yi. Okay, but if the value is very small, that if it is like the value d, okay, d indicates very small change, so in that case you can write dy1 plus dy2 plus dy3 till dyn. This will give you sigma I is equal to 1 to n delta. Instead of delta I have written dyi, but it cannot be written like this. Okay, this will be the incorrect method. In that case you have to write integration. Okay, this is the symbol of integration. Integration, you will just write dy. Okay, limits you can write it is from 1 to n. Okay, let's see if it is written like this, integration a to b dy, then this is called the lower limit of integration. It's called the upper limit. Okay, so this is called the upper limit. This is called the lower limit of integration, and this is called the variable with respect to which we are taking the integration. Okay, so let's see the formula number 1 of integration. Formula number 1, integration a to b. Please listen it carefully, try to understand, pause the video, or you can also play the video in somewhat lower speed, but try to understand this thing. It's very simple. Trust me, by watching this video twice or thrice you will be able to understand. Okay, and also don't forget to take a pen and a paper with you and write down these important things. Okay, so integration a to b, x raised to n, okay, variable should be x, gives x raised to n plus 1 upon n plus 1 is the first step you have to follow. Again, I'm telling you, this is x, sorry, this is n, so I have written n plus 1, and the thing which is there in exponent should be there in the denominator. Okay, just remember, the thing which is there in the exponent should be there in the denominator. Okay, so this was the first step. Also the limits will continue. Limits are from a to b. That limits will be like this. This is a and b. From where does this come? Just see, it comes from this thing. This is b, therefore I have written b over here. This is a, therefore I have written a over here. Okay, so this is the first step. The formula is not yet over. That will give, instead of x, at first we have to write b. Okay, then we can write b raised to n plus 1 upon n plus 1 minus. Now instead of x you have to write a. The answer will be a raised to n plus 1 upon n plus 1. This is our final answer. Okay, so what you have to do is, again, let us take an example. Example makes a formula very easy. If you have integration 2 to 5 x raised to 9 dx, then it will give, see once again, this is n plus 1, is also n plus 1. So first of all we'll write x raised to, instead of n we have 9, we can write 9 plus 1 upon 9 plus 1 from 2 to 5. That will give, instead of x you have to keep y 5, let 5 raised to 10 by 10 minus, instead of x we have to give 2, we'll get 2 raised to 10 by 10. Okay, so that is our answer. Okay, once again, first of all, write down this thing, pause the video, write down this thing. I will be deleting this thing. Yes, integration 3 to 6 x raised to 5 dx will give x raised to 5 plus 1 gives 6 divided by 6 from 3 to 6, and further the answer will become like this. X, instead of x we have to give 6, you get 6 raised to 6 by 6, minus, instead of x keep 3, we get 3 raised to 6 by 6. Okay, so this is how we can solve the integration. Okay, so this was the formula number 1 of integration. Similarly, if we have like this, a special case for formula number 1. Special case for formula number 1 is integration dx from a to b. Okay, nothing is given over here. There is nothing here. In that case, we have to assume that if there is x raised to 0, okay, we have to assume that there is x raised to 0, and that the answer will be x raised to 0 plus 1 upon 0 plus 1 from a to b. The further step will lead to, instead of x, first of all let us solve the bracket thing, x from a to b. That will give, instead of x keep b, will get b, minus, instead of x keep a, will get minus a. Okay, so this is a special case. It's very long. It seems to be very long, but we have a shortcut, don't worry. If you have integration from 20 to 30 dx, the answer will be 30 minus 20, that is 10. How it comes? See, this is a, this is b, so you have written b minus a. Okay, so similarly, if we have 20 and if we have 30, nothing over here, then we can directly write upper limit minus lower limit. Okay, so if we are having only dx, dy or dt, let us take one more example. Integration dt from 2019 to 2020 will give 1. How? 2020 minus 2019 if nothing is given over here. Okay, so this was the formula number 1 of integration. Now let's see formula number 2. Formula number 2, we are having like integration like this, k dx from a to b, or just kx raised to n from a to b, then the answer will be k integration a to b x raised to n dx. Don't worry, here the k is a constant, therefore k comes out of the integration, so that's why I've written k outside the integration. Okay, so k comes out. Now the answer of this thing is there in formula number 1. If you have written, if you are having a notebook and a pen with you, and if you have written, then you will recall this formula. It will be x raised to n plus 1 upon n plus 1 from a to b. That will give k b raised to n plus 1 upon n plus 1 minus a raised to n plus 1 upon n plus 1. Okay, so this is the formula number 2 of integration. Just write down this formula. You can also write directly the formula, sorry, the answer of this thing is this one. No need to write down all the steps. Okay, so let's see some examples from this thing. Let us have some examples. Integration 5x raised to 3 dx from 2 to 3. First of all, we have to take the constant out of the integration. Let 2 to 3 x cube dx, that will give 5 x cube will become x raised to 4 by 4 from 2 to 3. The next step will be 5 will remain outside. Instead of x we have to give 3, we get 3 raised to 4 by 4, minus, instead of x we have to give 2, we'll get 2 raised to 4 by 4. Okay, that will be our answer. You can also solve this thing further, but there is no need to do that right now. Okay, so this is the formula number 2. Now let's see formula number 3 of integration. integration f plus g dx. Yes, it is very easy. We'll give integration a to b f dx plus integration a to b g dx. Okay, just you have to open the bracket. For example, if we have integration 2 to 3 x square plus 3x raised to 5 dx, then it will give integration 2 to 3 x square dx plus integration 2 to 3 3x raised to 5 dx. Okay, so this is how you can follow the method of integration. Okay, further this can be solved with the help of formula number 1. This can be solved with the help of formula number 2. Okay, so further just write down this formula further and just add it, you will get the answer. So this was all for integration. Now the things which you have compulsory have to remember is number 1, that a differentiation, okay, d by dt of position always gives velocity. Okay, number 2, the differentiation of velocity always gives acceleration. Actually it is the change in velocity upon time taken, or we can say this is the change in position upon time taken. Of course the change in position upon time taken gives velocity, and the change in velocity with respect to time also gives the acceleration. Therefore dv by dt of course will be acceleration. Okay, the formula number 3 is integration. If we are getting answer somewhere like this, integration u dt from 0 to t, your answer will be u will come out, integration 0 to t dt, and that will give ut. Similarly, if you are getting like this, integration 0 to t or 0 to s, only ds is given, then the answer will be just s minus 0, that will give s. Okay, I will suggest you have to write all these 4 points 5 times. Okay, 5 times you have to write down this thing, each and everything. The list is not yet over, it will continue. Number 5, if you are given integral like this, integration 0 to t u plus at dt, then you have to open the bracket. Yes, by opening the bracket we'll get 0 to t u dt plus integration 0 to t at dt. That will give, yes, u is a constant, therefore it will come out 0 to t dt, plus here acceleration is constant. Okay, it should be mentioned in the first equation itself, u is a constant and a also is a constant. So if two constants are there, the constant will come out of the integration, that will lead to u into bracket t minus 0 plus a will get, see over here we have t raised to 1, so therefore the answer will become t square by 2 from 0 to t, and that will give ut plus a. Instead of t we are keeping t, we'll get t square by 2 minus 0, we get ut plus half at square. Okay, so this is the formula of integration. You have to write all these things. Okay, don't become lazy. Okay, you have to write this whole thing 5 times. Okay, the list is not yet over, please wait. Here comes the last formula. Number 6, if you are getting in an integral like this, u to v dv, that will give integration u to v raised to 1 dv, or we can write it will be v square by 2 from u to v, that will give v square by 2 minus u square by 2. Okay, so trust me, if you are writing all the, okay, first of all, before talking anything else, let me give you this homework. You also are supposed to write this thing 5 times. So trust me, if you are writing this 5 times and if you remember all these things in a very proper manner, Then the numerical, or we can say some MCQs are also there, which are on the base of this thing, and it will make your things or answers very easy, and you will score good marks. Okay, so 4 marks will be confirmed if you are able to recall these things in your examination. Okay, so let's proceed further. Here is the main thing, that is the homework. I've already given you the homework. You have to write 5 times those 6 equations, up to 6 you have to write 5 times, and another homework is there in the link given in the description. Okay, so go to the link given in the description, you will get your homework over there also. Okay, so that was all for today. So thank you very much. Myself is Kunal Pandya, and please subscribe this so that you can be aware of the new videos which we launch. Okay, thank you.